Hello everyone. So in this session we will have a look at the topic of Way Anova in our studio, and the supporting text can be found on the page My Stats Online and the data as well. So the one-way analysis of variance ANOVA is a parametric test which compares the variances to decide if there is a statistically significant difference between groups of two samples. The founder of the one-way ANOVA was the Ronald Fisher in the beginning of the 20th century. Major or basic types are one-way ANOVA, two-way ANOVA, or multiple-way ANOVA. One-way, why one-way ANOVA? Because the researcher investigates only one factor, in our case the garden, and this factor can have more levels. So let's try to create an exercise together, and let's read the file, and let's save this file into the object one way. I have saved the file into my folder with documents. So let's read it, and let's use the function attach so that we can work with the data attach one way. And let's have a look, how does the file look like. So we can see it has 20 observations, explanatory or independent variable factor garden has 2 levels, and ozone concentration in units pphm has quite big variance from 1 to 7, which is the maximum, and it is our dependent variable which will be displayed on the axis epsilon. The objectives of this exercise should be to find out if we can reject or accept the null hypothesis, which says that the means of two gardens are not statistically not significantly different. So let's straight away print on the screen the mean for each garden. So apply ozone garden mean, and let's see that the mean average or overall average for garden A is 3, and overall average for garden B in ozone concentration is 5 pphm. So let's plot. Let's plot the graph where we would be able to see what are the basic layout of these values. So plot from the first to the 20th point ozone, and let's use the split by color. And the garden B will have the red color and garden A will have the black color. Okay, that's it. In general, we can paint the mean for both gardens, which is 4. So AB line H equal to mean ozone, and color black And now we can also paint the residuals, which is the differences between our points and the mean. So again, from the for each point from the first to the 20th observation, create a line between between the mean and the exact point. And let's use the color gray. Okay, if we wish, we could also print the mean and the residuals for each garden separated, which you would find also here. The one-way ANOVA can be done manually, of course, or by built-in RStudio function. So let's use our built-in RStudio function. By this AOV, RStudio function, we can go for two main approaches. One would be the basic output, and the second one would be the LM output. So both are in general the same. LM output is providing slightly more information, so the level of the intercept, for example, and so on. So let's create together, for example, this lm output. So let's create the object ANOVA 2 and let's save inside the summary .lm. So let's save there the lm output of ANOVA ozone and the independent variable garden. He doesn't like something. Oh, I see here is a small typo, so let's remove that. And let's have a look. How does it look like? So ANOVA 2, you can see that the intercept stands for the mean of garden A is the 3, and then the mean of garden B is 2 levels higher, 3 plus 2, so the mean of garden B is 5. Probability of 0.0011. 1 is saying about 0.1 probability of obtaining data as extreme as ours, or even more extreme if two means really were the same. So based on this number, we can already see that we can reject the null hypothesis, and that the means of two gardens are significantly different. Another confirmation of this could be found based with help of F statistic, which is in our case 15, and we could calculate the critical value QT, and the critical value is calculated as our confidence interval 0.95, 1 and 18 degrees of freedom. So based on this, we can say that critical value could be calculated as QF. That's more suitable in our case, and the critical value is 4.4, which is much smaller than the F statistics of 15. And based on this, we can again say that the means of two gardens are statistically significantly different. So that's it basically. Thank you very much for your time, and I hope that it was helpful for you and that you will attend the next session again. Thank you.